Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Dr. Joseph. In today's video, I shall be taking us nutritive requirements in AB 1 to 2. Now, this topic is quite broad. This topic is very broad. Now, in reading this topic, you need not memorize everything on the textbook that is particularly this topic. Just read smartly and wisely. Sometimes you can be intelligent. It's also good you do things smartly and sagaciously. Now we are going to be discussing nutritive requirements. I'll not be killing myself stating the meaningless things there. Okay, I'm going to be giving the salient points, the point you need to at least the things that are likely to come out regarding this topic. Now let us get started. As the name implies, nutritive requirements. These are the nutrients required for the metabolic activities the body executes, which means that for an organism to survive in its environment, plant and animals, they must have moderate amount of nutrients, adequate amount of nutrients to enhance their survival. Now, in our discussion right now is going to be based on animals, okay? Animals, no, it's AB, animal and environmental biology, strictly animals, okay? Now, in this topic, we are going to be treating the macromolecules. The macromolecules are actually, we have protein, we have carbohydrates, we have nucleic acid, and we have lipids. No, fat and oils are collectively called lipid. Now, I know that vitamin is not categorized as a macro molecule, but it is also treated in chapter 1 of the textbook. They categorize 4 entities as macro compounds or as macro elements. They are carbohydrates, protein, lipids, and nucleic acid. These are the 4 entities they categorize as macro elements. But let us get started. The first thing we have to consider is lipids. I'll start with lipids. What are lipids? Lipids are esters of alcohols and long chain of fatty acid. They are esters of alcohols and long chain of fatty acid. All right, dash is an ester of alcohol and long chain of fatty acid. The answer is lipids. Take note of that. I told you that fat and oil are collectively called lipid, and the end product of fat and oil are fatty acid and glycerol. Now, since we've stated what lipids are, I want to also give you the most common alcohol in a natural lipid. Please, the most common alcohol in a natural lipid is called glycerol. Glycerol. Okay, you agree with me that glycerol is also called propan 1,2,3 triol, and it is produced from a saponification reaction. All right, so please take note of that. I said the most common occurring alcohol in in natural lipid is called glycerol, but the most common fatty acid in a lipid, the most common fatty acid in a lipid are: one, we have the butyric acid. Okay, please, before I go into this, please, we have saturated fatty acid and unsaturated fatty acids. All right, okay, let me use the word esters. Saturated esters, they have chemical formula as esters that are saturated. They have chemical formula as CN H2N plus 1 COOH. Fatty acids or saturated esters, they are confirmed to a general formula CnH2n plus 1 COOH. All right, but unsaturated ester or unsaturated fatty acids are confirmed to a general formula as H2N-1 COOH. These ones are for the unsaturated esters, and these ones are for what? Saturated ester. Please take note of that. I said the most common alcohol in a natural lipid is called what? Glycerol, while the most common fatty acid in a lipid are butyric acid. Butyric acid has formulas C3H7COOH. Now this butyric acid is found in what? Butter. Please take note. A butyric acid, which is a form of what? A saturated fatty acid, is found in what? Butter, and it has formula CnH2H7COOH. Number 2 is the caprylic acid. Caprylic acid has chemical formulas C617, okay, 677, okay, so this 15 COOH. All right, so this caprylic acid is found in coconut oil. Coconuts, please. Caprylic acid, which has this formula, is found in coconut oil, but butyric acid, which is this, is found in what? Butter. Now, number 3, you have the capric acid. Now, this capric acid has its formulas C9, 9 plus 9, 18, plus 1, 19, COOH. All right, so this capric acid is found in palm oil. It's found in what? Palm oil. Now, number 4, you have the palmitic acid. The palmitic acid, which has the formulas C15, H15 plus 15 is 30 plus 1, 31, COOH. Is found in palm oil. It's found in palm oil and what? Lard. It's found in palm oil and what? Lard. You now also have what? Stearic acid. Stearic acid is also found in palm oil and what? Lard. Please take note of that. It is very important. Stearic acid is C17. 17 plus 17 is C17, H35, COOH, which means that capric acid, palmitic acid, and stearic acid are all found in what? Palm oil. So please take note of this. It is very important. Which of the following is found in a coconut oil? Caprylic acid. Which of these is found in palm oil and lard? It's either to give you palmitic acid or what? Stearic acid. Please take note of that. Now we are still treating lipids. Now please, the hydrolysis of lipid, when lipid is hydrolyzed, oh god, this wiper is bad. The hydrolysis of lipid will produce the hydrolysis of what? Oh, it's recording. Good. The hydrolysis of lipid will produce 3 molecules of fatty acid. Take note of this, please. We produce 3 molecules of fatty acid and 1 molecule of glycerol. The hydrolysis of lipid produce which of these? 3 molecules of fatty acid and 3 molecules of what? Glycerol. Take note of that. Now, you also agree to the fact that the monomers of protein is called what? Amino acid. The monomers of protein is called what? The monomers of protein are called amino acid, and protein is called what? The polymer, while amino acids are called what? The monomers. Now, there are certain amino acids that cannot be synthesized. They are called what? Essential amino acids. That is, acids that that animals cannot synthesize are called what? Essential amino acid. Please, dialysis of lipids produces 3 molecules of fatty acid and 1 molecule of what? Glycerol. Please take note of that. It is very important. Now, I said that amino acids that the body of an animal cannot synthesize are called what? Are called essential amino acid. Are called essential amino acid. I'll recap. Acids the body of an animal cannot synthesize or produce is called what? Essential amino acid. What are some examples of this? They will ask you which of these is not an example of which of these is not an example of an essential amino acid, or please, I'm busy of essential amino acid and non-essential amino acid. Now, example of essential amino acid are tryptophan. Tryptophan is an example of amino acid. Lysine is an example of amino acid. Valine is an example of amino acid. Histidine is an example of amino acid. That is essential amino acid. Leucine is an example of essential amino acid. Isoleucine is an example of essential amino acid. Which one again? Threonine is an example of amino acid. Methionine is an example of what? Amino acid. So 1, 2, 3, 4, 5, 6, 7, 8. They are all examples of what? Essential amino acids. These are acids that the body of an animal cannot what? Synthesize. Now, the ones the body of an animal can synthesize are called what? Non-essential amino acid. Please take notes. Arginine can be what? Synthesized, but it is not so fast to meet the demand of what? The body. Arginine can be what? Synthesized, but it is not synthesized rapidly. It is very what? Slow. Please, I said the ones that the body can synthesize is called what? Non-essential amino acid. Examples are non-leucine. Oh, another example of essential amino acid is phenylalanine. Phenylalanine is also an example of what? Essential amino acid. Now, example of non-essential amino acid are non-leucine. We have alanine, tyrosine, glycine, non-leucine. Okay, we now have proline, citrulline. This one again. Then aspartic acid. Tryptophan, lysine, valine, histidine, leucine, isoleucine, threonine, methionine, phenylalanine are examples of what? Essential amino acid. Then I said non-leucine, alanine, tyrosine, citrulline, proline, glycine, and aspartic acid are examples of what? Non-essential amino acid. So please take note of this. It is very important. Now, the next one we are going to be treating is carbohydrates. Of course, the major function of carbohydrates is to produce what? Energy. An adequate amount of what? Energy, carbohydrates. Carbohydrates. The major function of carbohydrates is to provide needful energy that the body makes use of. Okay, now carbohydrate has a bond called what? A glycosidic bond. The bond present in carbohydrate is called what? Glycosidic bond. Glycosidic bond. Okay, now when I was taking us an elementary system in AEB 122, I told us that carbohydrates is an enzyme that neutralizes or that hydrolyzes the glycosidic bond present in the carbohydrate. I think that carbohydrates or carbohydrates are divided into two: polysaccharases and what? Glycosidases. They are the two enzymes that catalyze what? Carbohydrate, that hydrolyze what? Carbohydrates. Now the bond present in carbohydrate is called what? A glycosidic what? Bond. I told that the major function of carbohydrate is to what? Provide what? Energy that the body makes use of. During respiration, we need what? Glucose. We need glucose. During metabolic activities, glucose is what? Very, very important. Now let us get started fully. We have different categories of what? Carbohydrates. We have the monosaccharides. Examples of these monosaccharides are, we have glucose, fructose, galactose, ribose, arabinose, glyceraldehyde. So these are examples of what? Monosaccharides. These are examples of what? Saccharides. The sweetest form of sugar is fructose. It's found in honey and what? Fruits. The sweetest form of sugar is what? Fructose. It's found in honey and what? Fruits. Now glucose is what is needed during what? Cellular what? Respiration. You know, when glucose is oxidized completely, it produces what? 38 adenosine triphosphate and what? Carbon and oxygen. Okay, is it oxygen now? The mix of oxygen, carbon dioxide. Okay, that is 38 ATP and what? Carbon dioxide. Like I have 6 H12O6 plus this, the glucose we make use of, and oxygen to release carbon dioxide plus 38 ATP. Good. So during cellular respiration, in the presence of oxygen and glucose, carbon dioxide and 38 ATP are what? Released. Then plus water. This water is released though. Plus water. That is 6 moles of what? Water. So then plus 38 ATP. I think this question came out yesterday. 38 ATP was the answer. Now, that is for that. Then galactose. Galactose is found in yogurt and milk. Okay, galactose is found in yogurt and what? Milk. Now, please, under carbohydrate, we also have what is called disaccharide. Disaccharide is formed when two monosaccharides are joined together after eliminating water from them. That is, you know, monosaccharides, they are conformed to original formula as 6,6H12O6, then plus another monosaccharide 6,6H12O6. Elimination of what? Water from it. That is what? Condensation. Now this plus this, that is C6 plus C6, C12. H12 plus H12 is H24, then minus 2, H22. Then O6 plus O6 is O12, minus 1 is O11. So this is what? A monosaccharide, and it is what? A maltose. This is what? A maltose sugar. Now, disaccharides are formed when two or more monosaccharides are what? Joined together with the addition of what? Water. Examples are maltose, sucrose, and what? Lactose. These are examples of what? Disaccharides. They are examples of what? Disaccharides. Maltose is formed when starchy food is what? Acted on by the amylase. So the amylase is that enzyme that converts starch to what? Maltose. Therefore, the end product of carbohydrate or starchy food is what? Maltose sugar. Take note of that. And the enzyme is called what? Amylase. Amylase. Now, okay, let me introduce this. I wanted to tell us something. Maltase, sucrase, and what? Lactase. Maltase is an enzyme that converts maltose to 2 molecules of what? Glucose. Maltase is an enzyme that converts maltose into 2 molecules of what? Glucose. Then sucrase is an enzyme that converts sucrose into glucose and fructose. Sucrase is an enzyme that converts sucrose to glucose and what? Fructose. The lactase is an enzyme that converts lactose to glucose and what? Galactose. Lactose is found in milk. Sucrose is found in what? Sugarcane, Saccharum officinarum. That is how it is. Then maltose is found in what? Malt. During the brewing of malt, maltose is what? Present in it. So please, maltase, sucrase, and lactase, they are found in the small intestine. That is in succus entericus. Okay, that is what they act on. There is thread-like structures, all right, in the small intestine. Is called what? Succus entericus. Okay, and maltase, sucrase, and lactase are found in the small intestine. Trypsin and even epsin are found in the small intestine. Now, that is all about that disaccharide. Okay, is there another point I'm yet to drop? I don't think so. Okay, now let us now take polysaccharide. Please, the polymer of carbohydrates or the monomer of carbohydrates are actually end products of what? Carbohydrate, which are what? Maltose. All right, I can see that maltose are the monomers of what? Carbohydrates. So take note of that. Now polysaccharides. Examples of polysaccharide are chitin, glycogen, starch, and cellulose. Chitin, glycogen, starch, and cellulose are examples of what? Polysaccharide. The most abundant and important example of polysaccharide is what? Cellulose. The most abundant and important type of polysaccharide is what? Cellulose. Cellulose is formed when beta glycopyranose are linked. Okay, cellulose is formed when beta glycopyranose are linked together, but starch and glycogen are formed when the alpha glycopyranose are what? Linked together. Please, cellulose is formed when the beta glycopyranose are joined together, but starch and glycogen are formed by the linking of what? The alpha glycopyranose. Take note of that. It's very important. Of course, chitin is the type of exoskeleton, is a carbohydrate that makes up the exoskeleton of what? Arthropods, insect. and they actually contribute to what egg disease or molting. Now, then of course I'll explain others. Animals store carbohydrates as what glycogen, and you know that glucose is converted to glycogen in the liver by the in the presence of an hormone called what is it pepsin? No, insulin. Yeah, insulin. Insulin converts glucose to what glycogen in the liver. Glucagon does the opposite. So we are not doing that. This is what we are treating right now. Okay, so and polysaccharides. Now I told that starch is an example of what polysaccharides. There are two categories of starch. We have this marker is spent already, or is fainting. Or this marker has fainted. You see that they will check you. They will just check you. Amylose. Amylose is made up of linear and unbranched residue of what? Glucose. Amylose is made up of what? Linear and unbranched what? Residue of glucose, which means that the glucose found in amylose are linear and they are not what? Branched. Okay, take note of that. Then while the aminopectin, while the aminopectin is actually complex and branched, it's made up of complex and branched what? Glucose. Okay, please take note, the two forms of starches are amylose and what? Aminopectin. Take note of that. That is all about carbohydrate. Is another one. Okay, as I said, I'm not going to be giving you word for word. I'll give you the important one that you need. But looking at your textbook, I believe I've really done a lot on that carbohydrate. I've done a lot. And please take notes. Yes, nice one. You know cell wall. The cell wall in plants is made up of what? Cellulose. Alright? And again, the function of glycoprotein is to form what? The cellulose in the cell wall. The function of the glycoprotein is to provide protection in the what? Cell wall. You know the cell wall has what? Cellulose. Please, you know the cell wall in a fungus is called chitin. The cell wall in normal green plant is cellulose. Then the cell wall in a bacterium is called what? A peptidoglycan. Take note of that, okay? I think the next one is going to be what? Protein. Yeah, protein is the next one, which is going to be the last one for today. The Lord is good. So just go through this video over and over again. You understand it? It's very, very what? Simple. Now, you have protein. The major function of proteins are one, they are needed for good growth and healthy development. The major functions of proteins are one, they are needed for good growth and healthy development. Proteins are also needed to repair worn out tissues and what? Cells. They're also needed to repair worn out tissues and what? Cells. Right? Protein are also needed for what? Enzymic reaction. No enzyme is an organic catalyst, proteinous in nature, secreted by special groups of cells in both plant and animal that carry out the metabolic activities in the body. Okay, they are just like organic catalysts, and they remain unchanged at the end of what? The reaction. The fourth one, or number four, they also produce antibodies that fight against what? Foreign bodies. Okay, they produce antibodies that fight against foreign bodies. So that is some functions of what? Protein. Take note of that. It is very important. You also okay. No. Phospholipid bilayer. No, let me not bring it that now. Okay, now the bond present in protein is called what? A peptide bond. A peptide bond. The bond present in protein is what? Peptide. The one present in carbohydrate is what? Glycosidic. The one present in lipid is called what? Esters bond. That is for that. Now, when I was taking us alimentary canal in AB 1 to 2, I told us that the enzyme that act on protein is called what? Protease. It's called what? Protease. And there are two enzymes of protease. We have the we have the endopeptidase and the exopeptidase. The endopeptidase, they render the amino acids, they divide it into what? Different sections. They make it what? Vulnerable. That is what the endopeptidase do. Okay, now why the exopeptidase, they act on the terminal amino acid. They act on the terminal amino acid. Now the enzyme that converts protein to amino acid is collectively called what? Protease. Okay, and again, please take note of this. Nice one. The smallest form of protein. What kind of markers are these now? I thought I refilled them just now. Protein are broken down to peptone. Then peptone are broken down to peptide. The peptide is broken down to polypeptide. That is polypeptide. And polypeptide is broken down to what? Amino acid. Amino acid. Now, the enzyme that converts protein to peptone is pepsin. And of course, it's found in the stomach. The peptone is converted to peptide by trypsin, and this trypsin is found in the duodenum. Then peptide is converted to polypeptide by protein peptone. Okay. Now, for a better understanding, I'll remove this peptide, please. Yeah. Okay, peptone. Now put polypeptide. Polypeptide. The polypeptide is now converted to what? Amino acid by what? The erepsin. And this erepsin is found in the small intestine. Now, protein is converted to peptone by the pepsin. Peptone to polypeptide, trypsin. Polypeptide to erepsin is called what? Polypeptide to amino acid is done in the presence of what? Erepsin. These are the processes involved during the breakdown of what? Protein molecule. Take note of this. Chitin, which is a type of protein, is found in skeletal and cardiac muscle. Take note of that. Cardiac muscle. Chitin is found in skeletal and what? Cardiac muscle. Okay, take note of that. So at this point, we'll call it a day. And please, my next video is going to be on the water soluble vitamin and fat soluble vitamin. The fat soluble vitamin. All right, these are vitamins that are only soluble in what? That are only soluble in fat. Examples are the ADEC. That is vitamin A. Vitamin A called what? Retinol. And retinol is another name for vitamin A. Vitamin A also has the retinal, which means that it has the retinol and the retinal. The body converts the retinal to what? A retinoic acid. Retinol, retinal, and retinoic acid are collectively called what? Retinoid. Okay. Now, vitamin D is also called what? Calciferol. There are two categories of calciferol. We have the co-calciferol and the ergo-calciferol. Now, vitamin E is otherwise called what? Tocopherol. Vitamin K is called what? Phenoquinone. The inactive form of phenoquinone is called what? Menaquinone. So please, at this point, we'll call it a day. Okay. Why the water soluble vitamin? I'm just trying to make an introduction. The water soluble vitamin are the vitamin C and what? B complex. All right. So please, at this point, to call it a day, please memorize the essential and non-essential amino acid properly. Don't take one for the other. Thanks for watching, and do have a wonderful day.